All right, guys, this is our lesson on section 8.4. We will be working, you will be responsible, you may work more problems than that, but you will be responsible for 1 through 19 odd. I'm going to go ahead and break it into two parts. I'm going to go ahead and work a couple of problems on here and a couple of problems on this one, on the second part of it. Now, the material we're covering is the word problems for the previous section. We've worked vectors. Now then we're going to do the word problems for it. These problems are very similar to the problems that we covered in our comp class, our UIL test, our TMSCA test that we've gone over. We have vectors on that. We worked quite a few problems with vectors. Some of the problems we've worked exactly like we're going to work it in here. Some of the problems, especially when it got into bearings, and we used our program bearings, made it a little faster for us, but it's still just, we'll use law of cosines now instead of bearings, but we get to the same place, same concept. You're going to have this stuff probably figured out before I even talk on anything today. However, we are going to work a couple of these problems. Let's start off with number 3. It says an angle between forces. We have two forces. I like to draw one of them as horizontal. This makes it a little easier. That's 692. And we have another one of 423. And the resultant is 786. So resultant force out of this is going to be 786. And they asked me what this angle is right here. Find the angle between the forces. They asked me what this angle is here. Now, I've added two vectors together. We can use that parallelogram to set it up. It's the same thing if we do it like this. I'm going to move this force over here and I'm going to go tail to head. And I know the resultant, or the sum of these two forces, is going to be these two added together going tail to head. So this is 423, and we put these together. Now, they're asking me for this angle, but I'm going to solve for this angle, and I know that these two angles right here are supplementary. In other words, they add up to 180 degrees. So when I find this angle here, all I have to do is subtract it from 180 degrees, and I've got this angle. All right, now, we've got this triangle that we're solving. And there's two times we're going to use law of cosines that we talked about. If I have two sides and the included angle, I use law of cosines. If I have three sides, which is the case right here, I'm going to use law of cosines. I'm going to call this capital C and this little c. It just makes it fit. I could have called it capital A and little a. I could have called it capital B, little b. It makes no difference. But I'm going to use C and little c. And of course, we memorized our rule for law of cosines is c squared equal a squared plus b squared minus 2ab cosine of c. I've got c squared. That's going to be 786 squared equal to a squared. I can call either one of these a and either one of them b. So 692 squared plus 423 squared minus 2 times A, which is 692, times B, which is 423, times cosine of C. Now, at this stage of the game, I could go ahead and use inverse cosine function on it. In other words, I could take this, subtract that, divide it by this, take arc cosine, and I would have C. Or, which I figured that some of you have already done. Let me find my calculator here. I figure that probably both of you have already done this. You like to go to Math Solver. I know, Ty, that's really one of your favorite things to do. So we're going to go to Math, and we're going to go up to Solver. We're going to hit Numeric Solver, and we're going to plug in 786 squared. And then we're going to come down here and we're going to plug in 692 squared plus 423 squared minus 2 times 692 times 423 times cosine. Make sure better have their mode in degrees. Cosine of our variable, it'll show up as x, but we know that that is c. Going to hit OK. It asks us for a guess. I want to guess 80. And then I'm going to hit solve. And when I do, I come up with c equal to 86. And then, like we said to begin with, we have 180 minus 86. (180 minus 86 equal), and we come up with an answer of about 94. Okay, let's do another one. Let's do problem number 7. Now, before I start 7, we have a formula, and I don't think it's actually given in the book. They explain how you would get the formula, but I don't think they actually gave the formula. But we have a formula that tells us that force, if we've got a weight on an incline, that force is equal to the weight sine of theta. And this is the force that it takes to hold a weight in place at an incline of theta. Now, if I look on page If I look on page 759, I see that they worked a problem like that, and they've explained why this thing right here works. However, if we're in comp math, of course it's not comp math, but any math, if we have the formula for it, then we can just go ahead and work from the formula. In here it says it takes a force of 25 pounds. So I've got 25 equal to hold a weight of 80 pounds on an angle of degree theta, and we want to know what, in this particular case, it wants to know what that angle is. It says, what angle does the heel make with the horizontal? In other words, we've got a situation that looks like this. They're looking for this angle. When we have, they want to know what force it takes to hold this thing, which is a weight. Weight's going to go with the force of gravity, and that weight is 80 pounds. So what's going to hold that thing up there was that force. Now I can go to Math Solver again. Since we did that a while ago, let's do it without Math Solver this time. I'm going to take and divide both sides by 80. So find sine theta is equal to 25 divided by 80, implying that theta is arc sine of 25 over 80. So I take my calculator and I go second sine, and I go 25 divided by 80, and I hit enter, and I see that this thing is about 18.2 degrees. So I see that theta right here is about 18.2 degrees. Okay, I'm going to stop there a minute, and then I'm going to come back and work a couple of more problems for you.